Alright, so today we're learning how to use Pascal's triangle. Notice the first few questions here ask us to use Pascal's triangle to expand each binomial. Now in order to do this, you're going to need a copy of Pascal's triangle, which you can access next to this assignment. So I'm going to go ahead and just pull up a copy of Pascal's triangle. Now remember, in our last video we learned where this triangle came from. Remember, we said that each row is the sum of the two rows before it. So for example, to get to the 3, we added 1 plus 2. In order to get to the 10, we added 6 plus 4. And we followed that same pattern to fill in this entire triangle. Now Pascal's triangle was first discovered by a French mathematician named Blaise Pascal. And it has a lot of uses. In order to use it, though, you first have to understand that each row here has a number. And when mathematicians count, they typically start counting at 0. So this top row is actually row 0. The next row is row 1. The row after that is row 2. And then row 3. And so on. And you might notice that the second number of the row tells us which row we're on. For example, right here, we're on row 7. Now, keeping that in mind, we also can count in the terms, and again, we always start with 0. So, this first term is the 0 term, or term 0. Then we have our term 1, term 2, term 3, and so on. But again, keep in mind that when we count, we always begin counting at 0. So keeping that in mind, if we look back at our original assignment here where we've been asked to expand the binomial, notice this first problem we have is x plus 7 to the 5th power. Now to solve this, I can write out x plus 7 times x plus 7 times x plus 7, and I can do this 5 times and then distribute this out. But that's going to take me a lot of work, and so a shortcut we can use is to do this using Pascal's triangle. Now, to do that, I first need to notice that I am looking at a 5th power, which means I need to use the 5th row of Pascal's triangle. So if we come back to Pascal's triangle and look at row 5, notice that the terms that we have here are 1, 5, 10, 10, 5, and 1. So I'm going to be using those terms here on problem 1. 1, 5, 10, 10, 5, and 1. Then I'm going to be multiplying all of these A's and the B's. Now I'm going to be listing my A's, and I start here, but since it was a 5th power, I'm going to start with A to the 5th, and then count down. A to the 4th, A to the 3rd, A to the 2nd, A to the 1st, A to the 0. Now my second term is the B, and I'm going to be putting B's on these, but now I go backwards. So I start with my last term and call that one B to the 5th, B to the 4th, B to the 3rd, B to the 2nd, B to the 1st, and B to the 0. Then I'm just going to fill in addition signs, always addition signs, in between each term. Well, now I'm going to replace my A's and B's with the numbers. Remember that A was x and B was a positive 7. So this becomes 1 times my A, which was x, to the 5th power, times my B, which is 7, to the 0 power. Plus my next term, 5 times A, which was x, to the 4th power, times B, which was 7, to the 1st power, plus 10 times A, which is x to the third power, times b, which is 7 to the second power, plus 10 times a, which was x to the second power, b, which is 7 to the third power, plus 5 times x to the first times 7 to the fourth, plus 1 times x to the 0 times 7 to the fifth. All right, well now I just have to simplify each of these terms. So notice that I have in this first term 7 to the 0 power, which anything to the 0 power is 1. So that's going to cancel out and become 1. And I get 1 x to the fifth here. Plus, my next term, I have 5 times 7 to the first. Well, I know that 7 to the first power is 7. If I multiply that by 5, I will get 35x to the fourth. Plus, my next term now, I have 10 times 7 to the second. Well, I know that 7 to the second power is 49. If I multiply that by 10, I get 490 x to the third power, plus 10 times 7 to the third. Now I don't know what 7 to the third is, so I'm going to go to Google and check that. Here in Google, I'm going to type 10 times 7 to the third power. And Google tells me it's 3,430. So I know that this is 3,430 x squared plus 5 times 7 to the fourth. Again, I'm going to go to my Google calculator and type in 5 times 7 to the fourth. And I get 12,005. X to the first power, plus, in this last term I have x to the 0 power, which I already know is 1. So I can ignore the x, and now I see that I just have 1 times 7 to the fifth. Well, 7 to the fifth is 16,807, and of course if you multiply that by 1, it will still be 16,807. And here is my final expanded answer here on problem 1. Go ahead and try problems 2 and 3 using that same method, and then once you've finished, watch the next video, which will talk about the next part of this assignment.